Okay, yes. Hello friends, welcome to BISP Solutions. Myself Ashwin, and BISP is a tech company and provide technological solutions across the world. Now see here, today in our RNN bootcamp, we are going to see the recurrent neural network. As we have seen in our previous bootcamp sessions that how CNN works, right? How deep neural network works, right? So I recommend you to watch my previous video first, right? Now what is this recurrent neural network, right? So recurrent neural network works like inside this there are more than one or two hidden layers. Now hidden layers means what exactly? For example, suppose you might have experienced that on WhatsApp or any other messaging services, when you will type like I will call you once, then automatically on the header bar you will see the suggestions, once I reach home or once I get free, right? So these are called the suggestions. That means that is a machine learning, and machine is learning that exactly what you want to type or what you are thinking about, right? So that is called neural network working. Now here in this, it is one step ahead of CNN, right? So here the in this recurrent neural network, what happens here? Neural network used in deep learning consists of different layers connected to each other, right? For example, if one image is put in front of me, let's take an example that a dog is flying in the air and chasing the ball, right? Now what I will see, first of all I will see the dog, right? Then I will see in the background, I am showing you just a real life how our brain works, and the same thing will be applied in the machine learning. So suppose if I show you this image, let's take this image, right? Let me make it enlarge. Yes. Now what our brain will see, first of all our brain will see the dog, okay? Then our brain will see that behind this background there is a sky and the earth is a little bit away from this dog. So what our brain come to a conclusion that okay, this dog is in the air, mid-air, and like the dog is jumping, and in the mid-air it is catching a ball. So this is how, since we are humans, so we see the images and then we come to the conclusion. Now same thing we want to get it done with the help of machine learning, right? So machine learning, what machine learning is saying, that in this machine learning, if you see, now first of all what you will see, you will put so many images, right? Images pixel of two different breeds, right? Now first of all it will, in the first layer it will check, okay, it's a dog. Then in the remaining two hidden layers it will check first that exactly which type of dog is this. So then it, on the basis of colors, on the basis of shape, on the basis of images, with the matching with the library images, it will come to a conclusion that it's either it's a German Shepherd or it's a Labrador. Now based on, there are so many conditions. Now whatever the information feeded related to Labrador, that is one thing, and some information related to German Shepherd dog, right? So that is different. So first of all it will check that okay, it's a dog. That means in this first layer it will be finalized that okay, it's a dog. Secondly, it will be finalized that either one of either two of these dogs, it may be one, right? For example, if I put this Labrador image in the machine, right? So what it will check, it will check first the color of the dog, then the shape of the head, and based on this, on the second layer it will come to a conclusion that okay, it's a Labrador, right? So this is how the neural network works. Similarly, let's take an example of WhatsApp, right? In WhatsApp what happens, when you open the keypad and when you start typing, on the top of the alphabets you will see one bar. Inside that bar you will see the suggestions. The WhatsApp is giving you the suggestions. What type of suggestion? Like for example, if I type right now busy, will call you. Then automatically once I reach home, or once the word once will come, then when I will select that once, then immediately I will, once I reach home, right? So in this way the suggestions are given. That is what the RNN is doing. For example, feed forward neural network. Feed forward means it goes forward way. For example, let me give you one example of daily life. For example, 4 candidates are sitting in front of me. Now these 4 candidates are sitting in front of me. Okay, they all have given the correct answers. That's fine. Now I will check in the second hidden layer. In the first hidden layer I will check, okay, what type of communication skills they have. No, okay, no problem. I will check the communication. Some are good in English, but some are not good in English. Their vocabulary or the pronunciation problem is there. Then I will shortlist only those which are having good communication. Thirdly, I will see the attitude, the way they are replying the answer. That is also most important. So the third hidden layer will be the way they are replying. On the basis of that, I will judge, okay, this person can stay long with us, with this company or organization, because attitude, the way you speak, that tells a lot about you. So in this way, this is our third part. Then again, one more hidden layer. What I will do, I will check from which background they are coming, because whatever the work that we are going to give him, and what background he has come from, so that depends on. So basis on this, all these hidden layers, we come to a conclusion, finally one conclusion, that okay, these are the best candidates. Out of this we can select anyone, and finally only one candidate will be selected. Same thing is done here. Now in a feed forward neural network, information flows only in forward direction. Okay, that's fine. From the input nodes through the hidden layers, if any, and to the output nodes, there are no cycles or loops in the network, right? So that is why it is called as feed forward neural network. Now why recurrent neural network? Now see here, there are so many some points that forces us to select for a recurrent neural network. For example, what are the issues in feedback neural network? Number one, cannot handle sequential data, right? When there is a sequence of data, for example, sequential data means, for example, I am giving you the data of last 4 years sales data. It's a sequential data. Every time it is not necessary that we are giving them the images, that is a different part. But for example, we are giving them the sales order data for the last 4 to 5 years. It's a sequential data. Secondly, consider only the current input. It considers only the current input, whatever the current input is given. Third is cannot memorize previous inputs. Whatever the previous, for example, if I am taking an interview of a candidate, I will memorize that okay, he has given the correct answer, and then at the time of communication skills testing he could not reply properly, but still he did try, and after that, the way at the time of attitude testing, I can remember all these things. So decisions are taken based on this previous data only, right? Let's come another slide. By recurrent neural solution for feed forward neural network. The feed forward neural network means can handle sequential data. Now this recurrent neural network, what it does, it can handle the sequential data. Secondly, considers the current input also and the previously received input. Considers, for example, if a person has replied me rudely in the first round of interview, and in the second round, in the technical round, he has given the proper output, but at that time I will also consider that okay, he is good at technical, but what about the communication skills? So on the basis of this, if I take decision, that would be much better. In that case, I would be able to give the company the best candidate. Otherwise the person, those who test only technical part, if I ask my subordinate to take the interview, what he will do? He will do one thing only, he will test only technical part. So same thing is here. That was just an example. So consider the current input also and previously received input. So this recurrent neural network, what it does, it considers the current input and whatever the input received in the past, it consider that also. Third, can memorize previous inputs due to its internal memory. Okay, the previous inputs can also memorize due to its internal memory. Now see here, application in RNN, recurrent neural network. Okay, now if I show you this image, now this image at the very beginning of this session we have already discussed this. Now once again, now suppose if I feed this image into the machine, right? So what the machine will come to a conclusion that okay, this dog, a dog catching a ball in the midair. So this recurrent neural network is capable in analyzing the data like this also. Similarly, time series prediction. Time series prediction means suppose we are having the data of last 10 years related to transactions, any corporate data, let's assume. So in that case, anytime series problem like predicting the price of the stocks in a particular month can be resolved using an RNN. Okay, now so in this way, predicting the price of the stock in a particular month, so we use RNN for prediction of the series also, correct? Now let's see here, machine translation. You might have seen the Google Translator, right? Machine translation means, see, given an input in one language, RNN can be used to translate the input into different languages as output. For example, whatever I speak on the phone, it should be translated as per my choice. I want it into Chinese language, okay, Italian language, okay. I want that whatever I speak in English, I want that to be converted into French language. So anything is possible with this RNN, recurrent neural network, right? This recurrent neural network is capable in doing such type of task. Now natural language processing, right? So natural language processing means text mining and sentiments analysis can be carried out and using an RNN for natural language processing. So this is used for NLP, natural language processing. Whatever you type, it works on that your language and then it convert it into the English and then it works on it, right? So that is called NLP, recurrent neural network. Now see here how this recurrent neural network is used. A recurrent neural network or RNN is a deep neural network trained on sequential or time series data to create a machine learning model that can make sequential predictions. That means last year the rainfall or the rainfall record was this. So on the basis of that I can predict what will be this time. So that is called sequential. And then if you see here rotate anti-clockwise and compress the layer. Rotate anti-clockwise, all in all the base is that it will calculate the data, it will make the prediction based on the previous also, because it has a memory to memorize the previous data also. Clear? Now see, you can see here X is the input and Y is the output, and in the middle there is a hidden layer. Just give me a second. Okay, now here in the middle there is a hidden layer, so this H denotes the hidden layer. Now if you see the formula, H equal to new state, HT, the H is the new state at the point where the decision is taken. FC is the function with parameter C. HT minus 1, that is the old state, old state, based on old state also it takes the decision. Then xt input vendor input vector at time step 1, right? Now see how it works. Type of recurrent neural network. There are different types of recurrent neural networks. One is one to one, one to many, many to one, many to many. So one to one means what? Single input, single output. That means if I put the image of dog only, then okay, the output will be either dog yes or dog no. One to many means I put one input, but there could be many outputs. For example, if I put a building image, now it could be a school image, school building also, it could be a commercial building also, it could be a government building also. So there could be one to many, many to one. On the basis of so many images, I recognize that okay, this is the person. For example, if I feed 4 images of one person, and based on that, if the machine says that okay, this is the name of this particular person, in that case that is also many to one. Then many to many. So here there are many inputs, many outputs, and many hidden layers. Okay, so now let's come to some practical work. So let me do this. Okay, now this is my Jupyter notebook, and at the very first session I have already told you that download this Jupyter notebook, and based on that, because everything for practice purpose we have to do same process, right? Okay, now let's come here. First of all, I will create a new IPyNup file, interactive Python kernel, right? So now let's take RNN exercise. Just wait for 2 seconds. Okay, now here I have already created one notepad here. So let's do this. First of all, now see here, first of all, NumPy is used, that is for numerical calculation. Pandas is used for data calculation. Torch is used, right? Neural network, we have to import the Torch neural network. Then Optim is used for optimization. Minimum maximum scalar. Matplotlib is used for plotting the data. Torch.utils data equal to data loader and tensor dataset. This is the new thing that you will see. Y finance as YF. Right? Y finance, this is the main important. And now I am going to import these libraries. Actually we need to wait for 2-3 more seconds because it takes a little time. So okay, now it is done, it is called, and now what we are going to do here, end date. Now see here, end date, that is the today's date, and start date, that is the 1 January 2000. 25 years data, 24 years data. That means first of 24, no, total complete 25 years data, 25 plus 2 months data, right? So what we have done here, we have taken one data, right? yf.download. This is for just for testing purpose, and we are doing it for testing task. Load Apple stock price data. Ensure the dataset contains class column, close column. Now this close column is required here, right? Now suppose if I put here 1, okay, then what will happen? Normalizing the data right? We will do what? Normalizing the data. By mistake that double inverted comma printed. Okay. Now scalar equal to minimum maximum scalar, and prices scale, that is scalar dot fit to transform. So first of all, what we have done here, prices equal to data close. That means out of that Excel sheet complete data, what I have done, I have taken the column that is the data, that is the close column, right, and then reshaped it and converted everything into between -1 to 1. After that we have used the scalar equal to min max scalar and prices scale, that is scalar dot fit transform. Now fit transform, you will see, let's come here. Now see what has happened here. Create sequences, then definition, that is create sequence data square length, right? Now we have given square length, and now if I go down a little, sequence length, that is the 20 hidden layers, right? Now what we will do, we will just hit the enter button, and then now see split data into train and test. Again, now see we have been communicating with each other for the last 8 to 9 classes, right? 8 to 9 classes has been covered now. So this is the general process, that just splitting the data first, then converted into train and test category, right? Training X train, X test, Y train, Y test, right? Similarly X split and Y split. Okay, after that what happens here, convert to Pytorch tensor, right? Now see here, X train tensor, torch dot tensor, we have converted torch dot tensor, and then X train, Y train, X test and Y test. Clear? After that what we are going to do here, this is not as easy, it's a little difficult, right? It's not that much easy, right? So practice this and watch this video twice. Now see here, train loader, there is a loader that we call it as train loader, then data loader will load the data, tensor data set, X train tensor, Y train tensor, right? So for this we have used train loader, and the data loader will load these all data, X train tensor. After that test loader, there is one more thing, that is test loader. So test loader will load the data, then now see here, define RNN model. Now we are going to define, now here we have already defined this. How we have defined this, that is the init function, and after this hidden size, that is 50 neural networks will be created, then nn dot rnn input size, and then hidden size. Okay, and similarly this forward function, this is also standard forward function, and we use this size 0, ensure no h0 matches numbers, layers and hidden size, right? Okay, now how it works, now see here, Now you can see model equal to stock RNN, criteria that is MSE, mean square error loss, and then optimizer, we have used the optimizer optim.addm, right, and then model dot parameters comma LR, that is 0.001, and after this what we need to do, we need to give the training, right, we need to give the so here you can see epochs 20. I have taken epochs 20. See, 20 epochs means 20 repetition. Now 20 repetition will work, so definitely it will take a little time, so you have to wait. You must have the patience for this. Now see here, once I am hitting the enter button, now it takes a little time. Right now it is just working. Now see epoch 1. Okay, so let's wait. Epoch 1, epoch 2 has been running. We have to wait. So this epoch run, epoch takes a little time, right? Suppose if we take 10, so the accuracy, you will not see any accuracy in that. Okay, so now here epoch 4 has been completed. So all in all, what we need to understand that RNN is much advanced than any other machine language tool, right? Completed. Okay, 7 is completed. Okay, now why I am showing you this complete running process, because you should understand exactly how we have to work, right, on this. Okay, epoch 10 is completed now. Till then I show you something else. See here, 20 epoch runs. After that, what we have done here, model dot evaluation, and then evaluation, after evaluation we have plotted the data. That is what we have done. So let's wait for 2-3 more seconds. It is now nearing to complete. It's very close to complete. One more real life example. For example, if you send email, before you type something, email automatically gives you the, so you don't need to let's wait few more seconds, because now we have to conclude this. Now what will happen here, just a second. Here we have to extract the y predict test NP and y test NP, the differentiate between the prediction and non-prediction. So y pred test underscore NP equal to scalar dot inverse proportional to, look at this here, inverse transform, and here. Okay, so now I am going to hit the enter button, and now what next? Now see here what we have done from 1st of January. You look at this in the top of the page. 1st of January 2000, we have taken out the data from till yesterday. That means from 1st of January till yesterday. After that, if I show you this, first of all, let's check this APPL, Apple company, right? So they have just they have so many documents. So based on that, we have downloaded this. After that, load Apple stock price data. So whatever they were here, the price data. So the data is taken, reshaped, and -1 to 1. All the data will come to -1 to 1. After that, you see here prices. It has prices. One more thing, the here is that we have to calculate the prices. First of all, we have to take the close date, close column into prices, right? Then convert it into the reshape, and after that, scalar, minimum, maximum scalar, and price scaled, that is scalar dot fit transform prices. Then the next definition is create sequence, right? Again the same thing, that is whether it's a price scale or sequence length. Okay, so now what we have done, we have created the sequence. After that, we split the data into two parts, that is the X train and the Y train, and after that X train tensor equal to torch.tensor. So everything data is kept into the X train tensor, right? Torch tensor. After that, you will see here the data loader. So the train loader and test loader, we have the loaders, and data loader is used to load the data. After that, class stock RNN. Here one more function is there that we have used to evaluate the data. Then you will see here mean square error loss is calculated, because the loss is calculated at the time of predictions. Then epochs, 20 epochs we have executed just for this task. And after that, you will see you have to create the evaluation model also, evaluation eval model eval, and with torch.no gradient y prediction test equal to model. Okay, model X test tensor. Similarly, here test MSE, test RMSE criteria, right? So after completion of this RMSE and test whatever is here 6F, right? So here if you see RMSE equal to, this is the percentage, right? Percentage of success. So point here it is showing 0016 test, and then RMSE. After that, you will see Y prediction test NP, inversely transform, and then you will see here we have plotted the data. Now plotted the data, what this image shows, see blue actual prices is this for the last 25 years, because we have taken the data of 1st of January to January 2002 till yesterday. So that is why this is showing the sales of the last 25 years, and based on that we have deployed our scripting or the RNN model on this same data, and it has shown you the predicted sales, and almost it is completely equal. Okay, so that is what we have tried to show this, that here the predicted and the actual price is almost equal. Clear? So guys, this is another in recurrent neural network, and we have already seen this important scenario. So I recommend you to watch this video one more time, because things does not get clear in one attempt, right? So, and if you are a student, then you should watch more than one, and right, and if you have any doubt, you can put me a comment on the comment box. I will reply them. So guys, that's all for tonight, and in our next session we will see some other important topics, right? Thank you guys, thanks for watching the session.